Hello everyone and welcome. Now many of you know Bob Maurer and are familiar with his book, The Rotating Earth and Plate Tectonics. But if you haven't seen it before, it is freely downloadable from our website in PDF form. And you can also see Bob on our YouTube channel describing and explaining his own theory. So I would encourage you to do that. So what I want to try and do is explain why Bob has a problem with the current models. And I think this diagram sums it up. You have seafloor spreading and the oceanic crust moving in one direction and subduction there going underneath the continent. Can you see any problem with that? Can you think of anywhere on Earth where this arrangement actually happens? I'll show you the map in a moment. What's missing from this diagram is in fact the direction of the continents, because unless the continent is moving in this direction, you won't have any subduction. Subduction does not occur where the continent is not moving. I'll show you that in just a moment. So taking the reality on Earth that you need a moving continent in order to get slab pull, in order to get subduction, Bob thought to himself, well, maybe it's the other way round, and it's not the slab that's pulling the continent, but that the continent is moving and subduction is a consequence of the movement of the continental plates. That's what we're going to investigate today. So here's a map of the world. We're showing the spreading ridges and the subduction zones. And what we want to look for is a situation where ridge push can contribute, be added to the force of slab pull in order to move the continents, because that's what the proposed model says. If we look at Africa, it's really noticeable that there are spreading ridges all around, but that there's no subduction under Africa. And I think that's what got Bob thinking, because he comes from South Africa. Why is there no subduction under Africa? If you look at North America and South America, you'll see that the movement of the continent, as you would expect, is away from the mid-Atlantic ridge. But where you get subduction is where the continent is moving over the top of another plate on the other side. So, for example, the Nazca plate here, the ridge, if there's such a thing as ridge push, would be working against the direction of slab pull. So it's hard to see how you could have these two forces working together. So Bob's proposal is that you don't get subduction unless you have a moving continental plate over the top of the oceanic lithosphere. Let's go back a minute to this diagram that now has a direction of movement of the continents over the subduction zone. The question is, without seafloor spreading, which doesn't seem to be helpful, can slab pull be responsible for moving the continents over the top of the subduction zone? And Bob will say, well, this is rather like trying to run up an escalator that's going down. It cannot work. The physics is not supporting this model. You need an additional force. And where in the tectonic models do we see a force applied to the movement of the continental crust over the top of the subduction zone? Bob is actually quite scathing in his criticism of the Wilson cycle. If you can see that you have rifting and seafloor spreading, what's going on here in the cycle? Basically, the continent's moving in one direction, and then suddenly it's just reversed and it's going back the other way. There's no explanation for why the continent should be going in one direction at step 3 and in the opposite direction at step 4. And you might say this is from 1989, but I've just found this from 2019. Exactly the same thing. At step 3, the continent's moving in one direction. At step 4, it's moving in the reverse direction. No explanation for why that would happen. Well, Bob's reaction to all this is to propose his own model based on his own understanding of engineer as an engineer and his understanding of fluid dynamics. So he's taken on the left-hand side here an experiment that's done with a tube partially filled with water with a fluid, and if you rotate that tube to either direction, the fluid in the outside of the tube will move from the heavier side to the lighter side. This is assuming that it's not perfectly balanced to begin with, and so this seems to Bob. This seems to echo the rotating Earth, that we have a situation where the Earth is not a perfect sphere. It's not perfectly balanced, and it is rotating. And so his model requires an offset center of mass. What does that mean? It means that the center of mass of the Earth does not lie perfectly at the center of rotation. And the distance between the offset center of mass and the center of rotation, Bob calls the radius of eccentricity. So if you apply the model on the left to what might be happening in the Earth, you can assume that the Earth's crust can slide across the asthenosphere. It would move if the Earth is rotating and the Earth is not perfectly balanced, then the crust will slide from the heavier side of the planet to the lighter side of the planet. And that's basically Bob's model. Let's see if it's borne out by the geological record. Well, what we see at the breakup of Pangaea appears to be all the pieces of crust moving away from Africa over time. And that leads Bob to think, well, Africa must be the heavier side of the planet. And what we're seeing is a shedding pattern where all of the pieces of continent are moving away from the heavier side towards the Pacific, which is the lighter side. Then that tells him that the center of mass is probably underneath Africa, on the African side of the Earth. Not that the crust itself is heavier on the African side of the Earth, but that the center of mass of the whole planet is under Africa. So that seems, when you look at the movement of the planet since Pangaea, that does support Bob's theory. Does it support the slab pull model, the convection currents, the convection cells of Hess, for example? Could they support this kind of movement? And Bob says no. If you have convection currents, they're moving in all directions chaotically, and the heat between the different convection cells would commingle in the mantle over such a long period of time, and you wouldn't have that sustained movement of the continents. So that's Bob's theory in a nutshell. In place of the Wilson cycle, he proposes his own cycle. The Maurer diagram of lithosphere regeneration is presented here. You have a supercontinent cycle, basically, where the supercontinents break due to circumferential stresses, and the pieces of continent fly off in all directions. As the continental pieces move, the oceanic lithosphere is stretched, and magma passively will fill the gaps. As the continental plates continue to move under momentum, subduction starts to occur, and the oceanic lithosphere descends under the continental plate with the weight of the continental plate moving over it. What's not explained in the theory of slab pull is what happens when the slab breaks off, because the slab pull force has to be considerably reduced where the slab has broken off. and descended into the mantle. But the continental plates seem to just keep moving as they would, according to Bob's theory, under momentum. But how does that work under the theory of slab pull? So that's it in a nutshell. In August at Bob's conference presentation, this slide was shown as a summary, and this was put together by Stuart Harker, who's going to be joining us later in the meeting. So I'll leave him to explain the summary. I'm going to hand over now to Dow, who's going to explain something about current tectonic thinking with regard to Bob's proposal of an offset centre of mass, and also concerning the spin wobble force that the Bob invokes.